All right, so as we see in this one, analyzing the conditional statements. So if you look at it, condition means it's basically you're putting a condition there. Let's say if this happens, then this is going to happen. So that's what is the conditional statements are means. So for example, as we checked some examples last time, when n is 9, the n squared is 81, which is if n is 9, then n squared is 81. So those are called the conditional statements. So it's really important when you look at the conditional statements, you follow those order and just write it down as a statement. And then we can look at it more into it. Let me put in some example of how these conditional statements look. So that way you got a really good idea what's important in this one to focus on. Okay. Oh, it's still loading. Oh, there we go. So if you look at it, conditional statement if you look at it, a measure of angle A is 99 degrees, then A is obtuse. If it is a converse, you have to flip it. If A is obtuse, then a measure of angle A is 99. So it's flip. It's called the converse. When you flip it, this statement to this statement and this statement to this statement, that's you get converse. And then inverse, you just put it not to the statements. Hold on. Okay. So inverse is basically you apply not, or you can say simply not equal 99, then it is a not obtuse. So that's the inverse. The contrapositive is basically you flip it, or you switch around the inverse, which is like measure of angle A is not obtuse, then measure of angle A is not 99. In this one, if you look at it, first, the conditional statement, this one, and the contrapositive, they're true. So if you look at it, if A is 99 degrees, yes, it is obtuse. Agree?
Yeah.
And also, if A is not an obtuse, then measure of angle A is not 99. Agree on that too?
No.
It's not an obtuse.
Oh, yeah.
Right? So, but if you look at this converse, if angle A is obtuse, measure of angle A equal 99. I mean, it's not always true. It could be 100 degrees, right? So, sometimes they are true, but not all the time. So that's the reason it is really important. You need to know which one is always true and which one is false too. Okay, that's all right. Let's try one practice question based on the conditional statements. The statement is given to you is when n is 9, n squared is 81. First, you have to write a statement just like this using the if then. First, write down the statement. Yeah, if. No, first write down this statements, please. I want you guys to write it down, these statements. First, write down the statement. And then write down the converse for this. And then you write down the inverse. And then contrapositive. Okay, write down those, and then I'll ask you, and then you can just answer me.
Okay.
When you write the statement, you have to use the if and then. Those are called the conditional statements. In the question, they did not give you the if then. So what you write for the statement, if n equals 9,
okay.
Then n squared is 81. So that's what you need to write. That's good. So that's a conditional statement. Okay. All right. Continue the other ones. You need to write it down. It's on the statements wise, not just n squared is 81 and n is 9. You have to write it down because if this question comes into the test, you're expected to write if n squared is 81, then n equals to 9. Then only you get the correct point.
N squared does not equal 81, then 9 does not equal, n doesn't equal 9.
Okay, hold on though. But that's not the inverse. Inverse is for the statement. Okay? Inverse is always goes with the statement. So if you're writing the inverse, you have to write the inverse for this, not for the converse. Good, thank you. All right, so the next important notes on this one is it's a perpendicular lines. So in this one, the next information that you need to know is perpendicular lines. The definition of the perpendicular lines is basically the lines that they intersect at 90 degrees. Okay?
Okay.
Yeah. So, and if you look at it just right now, quickly, the perpendicular lines, they write it like this. Okay? L is perpendicular to M. That's a symbol for the perpendicular. So if you write it like this, it's a perpendicular. And how another one is called, this is parallel. Okay? And this is a perpendicular. That's a symbol for that. If any time you see L perpendicular M, that means line L, line M, or perpendicular. So that's the meaning of that information. So the next we're going to look at some question on the perpendicular lines, and we can see the information whether it is true or false. And let's see, Omar, can you see it? Can you see the screen? Can you read?
Yeah. Well, yeah, it says decide whether each statement about the diagram is true. Explain your answer using the definitions you have learned.
Okay.
AC is perpendicular to BD.
Mm-hmm. And okay, let's look into that first one. What do you guys think? Is it true or false?
The first one?
The first one.
Isn't it true? True?
Yes, because when you see this line right here, it's a perpendicular.
Because they make it 90 degrees.
90 degrees. So yes, it is a true. The first one is true statement. And the next one is angle AEB. That means AEB. This angle right here, and CEB. CEB. This angle right here. This angle and this angle. Or linear pair. Do you think it is true?
What does linear pair mean?
Linear pair means when you add two angles, it gives the 180 degrees.
Yeah, it does. So that's true.
Sum of angles is 180 degrees. That's called linear pair. Yes, it is true. Because you know that is 90 and that's 90, so it should be 180 degrees. Now let's look into this next one. Ray EA and then EB are opposite rays. EA is starting from here. Let me change color. EA is this, and then EB is this. Are they opposite rays?
Yeah.
Amar, what do you think?
Aren't they the same ray, though? Like, yes.
No. EA and EB. Look at this one here. EA goes like this.
They both intercept as E.
Yeah, but no, are they opposite? Yeah, they're not opposite. So it's false.
Oh. So opposite would be AE and EC.
That's right. EA and then EC are opposite. Okay? Good? Okay. Yeah. Okay, we're going to do some practice, whatever we learned. That way you can get a good idea how to do these questions. Okay, so we write the conditional statement using if-then form. So you can just tell me, or you can write it on the paper. Either way, it works. Okay. Okay, so the next one we're going to look into is, so we're going to say true or false. So we're going to take Let's see. I'll put it up there. Good, you guys did the number 4 correctly. Now let's look into the next one. So this one, it's basically, I'm going to read it for you guys. Decide whether the statement is true or false. If it is false, provide a counterexample. Okay. So if a polygon has 5 sides, then it is a regular pentagon. What do you guys think?
I don't know. Wait, I don't know my shapes, that's why.
Oh, okay. So it's fine. If a polygon has 5 sides, right? 5 sides means it's a pentagon. Okay.
Yeah. Okay. Okay.
It's a pentagon. When you have 5 sides, it's a pentagon, but it doesn't need to be regular, right?
Okay. Okay, so it's false then?
Yeah, it is a false. So, regular means is all the angles, all the sides has to be equal. But in this case, polygon has 5 sides. It doesn't mean it has to be regular. It could be it could be a pentagon.
Yeah.
Maybe like that. So regular means all the angles and all the sides are the same. All the angles and sides lengths are same. But in this case, we maybe or may not, so we don't know that. Okay. So it says write the converse first. Converse. What does the converse means?
Huh?
What's a converse means?
Converse is like
yeah, you just need to flip it. Okay. So you just need to flip it. That's called converse. And
so if x is greater than 0, then x is greater than 4.
Okay, so that's a converse. Okay. So first of all,
x can equal,
if x is greater than 0, then x is greater than 4. Do you think it is true?
If x equals 1, x is not greater than 4, x is greater than 0.
That's right. So that's a counterexample. So if it is not true, explain why. So that's where you get the counterexample. If x is 1, it is greater than 0, right? But not 4. So that's a good counterexample. That's good. So that's what it is about. Explain why it is. So the next one we're going to look at is called a biconditional statement. So biconditional statements means if and only if. That's what you see in there. So let me get an example here. I'll also get you some examples out there. So write the definition of the perpendicular lines as a biconditional. So when you look at this one, what is a biconditional statement is if then, if and only if. If this only happens, if this is only happens. So I'm going to write down what is a biconditional means. So biconditional means if and only if. That's a biconditional. Conditional means if then. Conditional, if then. That's called conditional. Biconditional is if and only if. So if you look at it right here, definition, if the two lines intersect to form a right angle, then they are perpendicular. So that's a statement. And then you can write the converse, you just flip them. The two lines are perpendicular, then they intersect as the right angle. And then finally, biconditional, you can say that if the two lines are perpendicular, if and only if they intersect at a right angle. Okay, So that is called the biconditional. So all you have to do is like add if and only if. Does that make sense?
Okay.
So the first one, yeah, that's it. Very simple. Conditional means if then. Biconditional means if then only if. That's what you need to write it.
And then, or if then what?
If then only if.
Okay.
Right here. You see this? Biconditional. That's if then only if. And the conditional means, like we learned already, if then. If this and then, like that. So the next one will be an example to just like what we did right now for the biconditional. Let's see. Arjun, read the question.
Okay. Can the statement if x2 minus 10 equals x plus 2, then x equals 4 be combined with its converse to form a true biconditional?
Let's talk about it.
So, if then only. So, if x squared minus 10.
First, you have to create the converse statement first. Create the converse statement.
So, if x plus 2 minus 10 equals x plus 4, or x plus 2, then x equals 4.
So that's a statement. They gave it to you already. Now the converse means you have to flip it.
If x is 4, then x squared minus 10 will equal x plus 2.
Yeah. That's what it is. And then you can write it biconditional. And then biconditional is just you use the same thing, but you write it if and only if. Okay. So what you need to write is if x equals to 4, x equals 4, then you write it if and only if x squared minus 10 equal x plus 2. That's it. Does that make sense?
Okay. What? Well, okay, if it's Tuesday, I have art class. And then on Friday, that person has gym class.
So that's the conclusions. Like from the given statements, you have to come up with the conclusions. This is one of the, you can see those challenging questions, because you need to look at the statements. From that statements, you have to come up with the conclusions. Okay. Now let's go back and review what we did today so that we have a pretty good idea for next class. So pretty much learned is conditional statements, which is converse, inverse, contrapositive. And then we did an example. We talk about the perpendicular lines and the symbol of the perpendicular lines. And also based on the given information, whether we're going to decide whether it's true or not, and all those things. And also we learn about the counterexample. Counterexample is also a really important question that you need to remember that. And also we did the contrapositive or the biconditional statements. Biconditional statements if and only if, and then the other one is if then only. Okay. Any questions on this one so far?
Okay. Nope.
Oh, all right. That's good.